cosine function is similar. We're still talking about something rotating around like this point here, but now instead of being interested in how far this dot has moved along the y-axis, we're interested in how far it's moved along the x-axis. Okay, so when the angle is 0, that means with a maximum distance along the x-axis. So what is the cosine of 0? 1, yes, because again this is 1, this length. It comes around here, gets to the top at 90 degrees, or pi over 2. What's the cosine of 90? 0. Okay? Go beyond 90 degrees here. Now we're interested in how far along the x-axis we've gone. It's gone negative. So now we go negative again until we get to 180 degrees, -1, or pi, -1. Carry on coming round, and you can see similar sort of idea to the sine, but it starts at a different point. Instead of starting at 0, it starts at 1. So the cosine, if we now go to autograph and put in the cosine function, so let's close this for now, open a new page, type in an equation here, y equals cosine of x, cos x, hit OK. It draws the cosine function for us. Again, I'm interested in just this after 0 point here. If I want to make it a bit bigger, then I can use these buttons here. This allows me to zoom in on the y-axis, so it stretches out the scale and I can see a bit more. Now we can see, again, I'm in radians at the moment here. So if I hit default scales, I'll see one cycle in radians, which is 0 to 2 pi again, so 2 pi here. But now you can see it's starting at 1, going to 0 at 90 degrees, and so on. So that's the cosine wave. Again, if I go to degrees, I can see the same thing in degrees, so 0 to 360. So let's put the cosine wave into the notes here. One complete cycle. So there's the cosine wave, okay? And we can relate it to this. If I'm starting at 0, it starts at 1. We're not often interested in the cosine wave because that's what's happening along the time axis effectively. So if this x-axis was time again, we're not really often interested in that. We're interested in what's happening to something else along the y-axis as time is going by. So not such a common function. However, if we look at this and the previous one, we can see where the sine and the cosine ratios come from, because if we look at the triangle in the sine function, that's the opposite to the angle. Sine is to do with the opposite side. That's where that comes from. And we look at this one, the cosine is to do with the side adjacent to the angle, which is this one. So that's where that comes from.